Okay, so let's see. I think we left off here. We haven't done this one yet, the rectangle. Yes, no, maybe so. So the diagonals of a rectangle are 12 inches long and intersect at an angle of 60 degrees. Find the perimeter of the rectangle. So let's draw a picture. I've already drawn the rectangle. Let's draw the diagonals. The diagonal is 12 inches long and intersects at a angle of 60. It doesn't, I guess, it looks more like a 60. Say that one 60. It doesn't really make a difference. But then on rectangle, opposite sides are congruent. So we know that this is the 90. If indeed that's the 60, yeah, it has to be. That has to be the 60. Yeah, which means the 30 would be up here. And this would be 30 also. What side are they giving? Those are two special right triangles. What side are they giving me? The hypotenuse. What should always be the first side that you find if you're not directly given it? The short leg. Short leg. How do you turn a hypotenuse into a short leg? Divide by 2. So let's call let's just call these x. Let's just, for the sake of discussion, let's call these x and let's call these y. So x is the short leg. It's the one that's across from the 30. So the x's would just be 12 divided by 2, which is 6. Now that you have a short leg, how do you turn a short leg into a long leg? Multiply by square root of 3. Multiply what? The hypotenuse or the short leg? The short leg. 6 cannot be multiplied by square root of 3, so it just stays at 6 square root of 3. Right now, this is a perimeter problem. They want us to add all the sides up. How many sides of the rectangle measure 6? Inches. How many sides measure 6 inches? 2. So there's 2 6-inch sides plus how many sides measure 6 square root of 3? Awesome. This gives you 12. This gives you 12 square root of 3. Can 12 be added to 12 square root of 3? No, they're not like. If they want you to remain exact, meaning you can keep the equal sign, you have to leave it like that. If you are allowed to round, then if you're told to round, do they tell us to round here? I don't see anywhere where they're saying to round. So you would get the square root of 3, multiply it times 12 and hit equals, and then add an extra 12, and then that would give you the perimeter but rounded. Depends on the directions. This and Pythagorean theorem, yeah. Which remind me if we finish, there's one more thing because I just saw the quiz now for the first time, so there's one more thing I want to go over with you guys in regards to Pythagorean theorem. We should have time. Any questions? Okay, so they want us to find CE and find Y. How many triangles do you see there? 3. There are 3 triangles, and actually all 3 triangles are 30, 60, 90 special right triangles. Because if this is 90 and this is 30, that means this has to be 60. If this is 90 and this is 60, this has to be 30. And then on the big triangle, we already can tell all the angles are marked. One is 60, one is 30, and one is 90. Okay, so it looks like Y is acting as the long leg because it's across from the 60 on the medium side. There's like a little baby triangle on the left. There's like a medium-sized triangle on the right. and then we have the big overall triangle. So y is the long leg. I would like to then find the short leg. But the short leg here, it looks like it's an altitude. That's not given to us. But they do tell us that a over here is 10 square root of 3. On that little baby triangle, what is that acting as? It's the hypotenuse.
Which one? A, B?
A. See, on the big triangle, on the big triangle, yes, the A is the short leg. But on the little baby one, it's the hypotenuse because it's across from the 90. And in order to find y, and for that matter to find CE, because CE is part of the little one, I'm not focused on the big one. I'm focused on that little baby one. So let's first find x. X is the short leg on the little baby triangle there. How do I go from long leg to short leg? You're supposed to divide by the square root of 3, but I also gave you another option, depending on what number they give you, to try to avoid a nasty little skill known as rationalizing a denominator. That if you want to, you can also multiply times square root of 3, but then divide by a regular 3. But since the measurement they're giving me already has a square root of 3 in it, I'm going to choose the division one because that's going to work out best. Because I can take this 10 square root of 3 they're giving me and just divide by an extra square root of 3. What happens to the square root of 3's? They cancel, so x is 10. Not necessarily that I wanted to know x, but that's going to help me because now I can do. Actually, I confused myself. Let's hit the rewind button. I confused myself. I just finished saying that we're hypotenuse and I treated it like a long leg. I'm sorry, I didn't mean to confuse you. We're going from hypotenuse to short leg. X is still the short leg, but yeah, it's not divided by 6, it's dividing by 2. Sorry. So in that case, I have no choice. Let's divide by 2. Did I confuse anybody there? It's the hypotenuse, not the long leg. Like when we stated it was the hypotenuse. So go from on the notes, so go from hypotenuse to short leg, dividing by 2. Since the 2 is not in a square root, it's going to be 5 square root of 3. Then I could find CE. CE is the long leg of the little baby triangle. How do I go from short leg to long leg? Yeah, so I take this short leg that was there, and I multiply by an extra square root of 3. What happens when I multiply a square root times itself?
I know, it takes a square root of it.
It takes a square root of it, good. So that's just going to be now 5 times a regular 3. So somebody might say, well, but wait, mister, isn't that 9? Well, no, okay, it's a square root of 9. If you're going to call it 9, yeah, because they're both on the inside, fine. Let's call it square root of 9. What is the square root of 9?
3.
It's still 3. C is 15. That was one of the numbers that they were looking for. So we got that. Now we can shift over to the medium-sized triangle. And that CE that we just found, since it's across from the 30, what leg is that on the medium-sized triangle? That is the short leg. What side is Y? Which is the other thing they wanted us to find. No, it is the long leg, yes. Yeah, because the hypotenuse is over there. So it's the long leg. So how do we go from short leg to long leg? No, short leg to long leg. Multiply by square root. Nothing else can be done without rounding, so. Any questions on that one? So here they want us to find G and H. Oh. It looks like what type of a triangle is that? It is a 30, 60, 90. What type of triangle is this?
Right, I saw.
Also known as a 45, 45, 90. And then over here on this side, those are not special right triangles, but it looks like I don't need them to be because they're giving me two different side lengths. So all right, so let's see. It looks like we're gonna have to start with G. And then actually, yeah, we might need to use that 45, 45, 90 to get a measurement. Because we have the angle measure, but we need a side length. We don't have any side lengths over here. So we're gonna have to kind of use these to make it their way over here. So it looks like on the right side here we have a rectangle. So if this is G, that means that this is G. And if this is isosceles right, that means that that's gonna be G also. So finding G is gonna help me out. How could I find G? Since they give me two sides of that triangle, how can I find G? Let's take a step back and realize that math is cumulative. So you're not only responsible for what you did on one individual day, you're also responsible for what you did before. When you take this next quiz on Thursday, it's going to be both on special right triangles, but also Pythagorean theorem. If they give you two sides in a right triangle, use Pythagorean theorem. Can anybody tell what this is a Pythagorean triple? Can anybody tell what it's going to be? Okay, then let's do it the long way then. It's a 5, 12, 13. It's just that they were multiplied by 10. So we're going to end up getting 50. But what's 120 squared? Is that 144 and then 2 zeros? And then this is 169 and 2 zeros, and then we're going to go minus. So G squared is equal to 2,500. Yep. And then square root G is 50. So we got G already, which means that if we work our way around, that means that this ends up being 50 units. It looks like they have it in centimeters there, but that's from the answer key. What leg is that acting as in the 30, 60, 90? G is 50. That means this is 50, which means that's 50 there also. On this 30, 60, 90, what leg is this acting as? It is a short leg, and it's across from the 30 degree, which is great. We love having a short leg. We want to find H. What is H? Good. How do you go from a short leg to a hypotenuse? Just times 2, sure. So 50 times 2 is 100. So Robbie, is that a new educational strategy I'm not aware of? Yeah. Okay, what is it? How many triangles do we see here? 3. What types are they?
Right triangle.
Three triangles, right? The two of them should be easy to identify. Yeah, there's two 30, 60, 90s. Okay, because this is a 30, 60, 90. On the right side, we also have a 30, 60, 90. What's the big one? Equilateral. Look at the angles on the big one. If this is 60, this is 60, that means this must be 60. Equal angles means equal sides. So if this is 11, this is 11, and then this whole side over here is also 11. Huh? And x is gonna end up being 5.5, but let's just use what we learned from special right triangles to prove that. Okay, because yeah, when you have any type of remember equilateral triangles are types of isosceles. When you have an altitude drawn out of a vertex angle, that altitude ends up being a median, an angle bisector, and a perpendicular bisector. It ends up being every single type of so it's cutting out of the side in half. But let's pretend we didn't know that. What side is this 11 acting as in the special right triangle? The hypotenuse. How do I go from hypotenuse to the short leg, which in this case is x? And look at that. I ended up with 5.5, which I know we don't want decimals, but at least we're not rounding there. You can leave it as 11 over 2 also. Divided by 2. That's what you said. Where'd you get the hoodie from? Yeah, that's fine. There's no snow flurries in here. There's a potential for boredom. There's like a 70% chance of boredom, but still, skies are clear though. And then how do you go? The y is acting as the long leg. How do you go from short leg to long leg? Yeah, they have to find both x and y. Same exact type of diagram. Yeah, but let's just use what we know about special right triangles, right? And then once we find y is going to be the same as x because it's equilateral. On the special right triangle on this 30, 60, 90, what is the 12 acting as? What long leg? Okay, so I think of a way to not confuse you. Let me try something first, and if I confuse you, then we'll just go away from it, right? So if this is 60, and they tell you that these two sides are the same, that would mean that this is 60, right? Okay. And yeah, they only tell you that these two sides are the same, but because this is 60, this is 60, that's 60, it's equilateral, so the x down here is the same, right? Well, you would agree then that this little segment here, which is the short leg, that's half of x. So I could say half of x is the same as saying x over 2. So x over 2 is going to be equal to, what is the conversion to turn a long leg into a short leg? You're supposed to divide by square root of 3. But I only advise you to do that when you already see a square root of 3 or some multiple, like let's say this would have said 12 square root of 15. Well, I have a number in a square root that's divisible by 3, so yeah, you would just go ahead and divide by square root of 3, and you would end up with a 5 on top. The whole thing is that you can't end up with that. That's not the simplest form. You can't end up with a radical on the bottom. So that's why I gave you an alternative. The alternative is to get the measurement that they give you, which is 12, multiply it by square root of 3, but then divide it by 3. Have I confused you there yet? Because if you can't follow that, then just do it in little bits and pieces. Just give this a new name, call this Z if you want, but you're still gonna have to know how to do that anyways. The only thing is I've saved you time because now when I do end up finding x, since I properly defined x, I'm gonna actually have x. I don't have to do anything else. I'm actually gonna have what x is, and because it is equilateral, whatever x ends up being, y is gonna end up being 2. How do you, somebody noticed that I ended up, by coincidence, making a proportion? How do you solve a proportion? Cross multiply, so 3 times x is equal to 2 times 12 square root of 3. So 3x is equal to 24 square root of 3. How do you get x by itself? Divide by 3. So x is 8 square root of 3. If x is 8 square root of 3, what's y going to be? If x is 8 square root of 3, what's y going to be? 8 square root of 3. It's the same thing. They're both equilateral. X is the entire size, y is the entire size. And then, but you might be like, but mister, though, I don't get it, though. What do you mean? Well, I thought, isn't y the hypotenuse? Okay, fine, let's do it that way then. If this entire x ended up being 8 square root of 3, what would this little half part of it be? What's half of 8 square root of 3? 4 square root of 3. And to go from short leg to hypotenuse, you're supposed to double it, right? So what's 4 square root of 3 times 2? How many of you bothered to get started on the assignment yesterday? Either one, either the digital one, the written one. It's gonna help. Charisma, don't you lie, because you came into this morning and asked you for help on number 1. All right. Well, anytime that's left over, I don't have the computers today, so we'll just work on the written one, whether or not you're gonna do that one. And tomorrow we'll have the computers. But before you get there, let me go back and go over one skill that I saw on the quiz that we didn't necessarily go over. That we didn't necessarily go over on the notes before. So they're gonna ask you to identify whether a triangle is acute, right, or obtuse. Oh yeah, but they're not gonna give you a picture of the triangle, so you might want to listen. They're not gonna give you the angle measures either. They're gonna give you side lengths. So watch. Natalie, give me a number. What? 30. Okay. Nice. Healthy. Shaughnessy, give me a number. Okay. And you want it upward? Okay, then Alisa, give me a third number. 18. All right. So the quiz is gonna be on Pythagorean theorem and special right triangles. If they give you side lengths, you can tell what type of triangle you're gonna have by using Pythagorean theorem. A squared plus B squared is equal to C squared. Okay. Now I don't necessarily know that this is gonna be well, actually I do know this is not gonna be a right triangle because you just came up with numbers off the top of your head. Because I doubt it's going to be. The hoodie made it back on the top of your head. But if this were to be a right triangle, what would have to be the legs? What are the two shorter sides? What are the two shorter sides? 17 and 18. So 17 squared plus 18 squared would have to be equal to 30 squared. So listen carefully. If those two numbers end up being equal, then we have a right triangle. If we end up being equal, we have a right triangle. That part is not new. We have to, and actually I believe that was part of the notes. If we go back to the notes, I'll open them now. If we go back to the notes, we can check it, and we had someone we plugged in to see if we had a right triangle. Okay? If 17 squared plus 18 squared gives me 30 squared, then these three side lengths would end up giving me a right triangle. Okay? But what happens if they're not equal? Yeah, we know that they won't make a right triangle, but what triangle will they make? Well, think of it this way, right? Let's say that these are legs. if it's because the hypotenuse is too big, what type of triangle would that end up being? Of 2. So if this side ends up being the bigger side, once I go ahead and square these, if this ends up being the biggest, it's obtuse. If these two together end up being the biggest, then it's acute. Huh? It's obtuse season? I wrote it right. What are you saying? Oh, you're saying this particular one here. All right, let's see. Let's find out. 17 squared is what? That 289? Yes, sir. 289? And 324. Plus 324 would have to equal 900. 613 is obviously not equal to 900, so we know it can't be right. And because the number over here is bigger, that would be obtuse. Does that make sense? Do I need to do another example of that? If once I add these two together, like let's say Natalie didn't love the number 30, let's say she loves the number 20 instead. Well, that number would still go there because it's the biggest one. If it's gonna be right, that would have to be, it's bigger than 17 and 18. You have to make sure the legs are the two smallest numbers and the hypotenuse is the biggest. Okay? So but then here you would have gotten 400. And 400 obviously is not equal to 613, so it can't be right. But now the bigger side is coming from the legs, some of the legs. So that means that would have to be acute. Oh, that one. Yeah. If the left side is, assuming you write it in this order, legs on the left and hypotenuse on the right. If the left is bigger, it's acute. If they're equal, it's right. If the right is bigger, it's obtuse. So that will show up on the quiz. Well, it actually doesn't make a difference because if I would have put the 18 and then the 17, you'd still get the same thing. But what has to be true, what has to 100% be true, is that the biggest of the three has to be where the hypotenuse goes. Yeah, there's no reason not to put them in order. Yes, yes. The short answer to your question is yes, put them in order. There's no reason not to. You don't have to, but there's no reason not to. Okay? Okay, so you got 10 minutes left. You can work on the written packet tomorrow. I'll have the computers here. So if anybody wants to work on the Khan Academy, they can. Just to have, how many of you plan on working on the Khan Academy for the assignment for the week instead of the written one? All right, so I'm only gonna bring one card then. I'm not gonna bring two tomorrow. I'll just bring one card. And then if anybody gets ahead on the written one and you want to use the computer to submit your answers, you can do that too.